So welcome to this Reservoir podcast, which is being done in collaboration with the UK Construction Industry Taskforce. The purpose of this is that we're digging into the topic of safety glass, particularly in the context of fire safety performance and the external envelope of the building. We're going to be looking at the types of glass, we're going to be looking at the challenges there is in the industry currently, and also a bit of a future direction, which we're hoping will give a great context to where the use of glass currently is and where it has been in the past, and also some of the uncertainties which currently are affecting the sector quite significantly. I'm joined today by a combination of three glass experts. The first is Graham. Would you like to introduce yourself?
Yes, I'm Graham Browder from ESG Group, Commercial Director. Been in the industry now for 25 years.
Fraser.
Yeah, Fraser Caithless, Sales Director for Glass Express. Similar to Graham, I think I'm about 25 years now as well. Worked for a glass manufacturer in Guardian Industries and in various processes since then.
And James.
James Allen, work for a family business in the glass safety risk assessing part of the industry, and also on the Construction Industry Taskforce with Nick.
And I'm Nick Haughton from Sapphire Balconies, and I'm the host of the Reservoir podcast. And I've been in the balcony world for 20 years next week. So to start off with, to get a bit of a foundational context here, I think it'd be good to start off with what is a safety glass, and what's it actually defined as under the British standards?
So the British standard defines it as a glass type that will not cause life-changing injuries. Most people assume when we talk safety glass, tough and monolithic glass. So in terms of the glass that breaks into small rounded chunks, which is obviously less dangerous for individuals, but laminate glass also qualifies as a safety glass. The concern there sometimes is that whilst laminate glass contains annealed glass, which is not toughened, although you can get toughened laminate, people do tend to view safety glass as monolithic toughened glass, but it is both.
Yeah, so tell us a bit about the types of glass, Graham, because there's a number of parts we'll unpack as we go through this, but we'll look at the laminate separately at this stage. What are the practical differences, and talk us through the differences between annealed, toughened, heat strength, and so on.
So as a processor, we take the glass in anneal form, so that comes from the float manufacturer, and we'll take it through the process to what the customer wants at the end of the day. You could start with toughening, so we'll edge it, cut it, edge it, potentially drill it and toughen it to make toughened glass going through the furnace. We can take that toughened glass, laminate it into a toughened laminate. Variations of that. You've also got heat strengthened glass, which goes through the furnace, slightly different process. We can have heat strengthened laminate, and then there's also float laminate. So there's a few variations. We'll take the float glass and process it into a different end user requirement.
So float and annealed being the same thing, are they?
Yeah, technically, yeah. Yep.
And how does it actually become toughened? What is the process here, which you guys will be applying in your factories?
Yeah, so it is literally going through our toughening furnace. So we'll heat the glass up, depending on the glass thickness. You've got different cycles and different programs. Then we go through into a quench to cool the glass down again. If the glass broke at the front end of the oven, it's going to break into sharp shards. If it breaks at the back end of the oven, it's breaking into small, safer pieces of glass.
And so to toughen it, we're putting stresses into the glass,
yeah,
and that's by a process of warming up,
heating and cooling.
Yeah. So you mentioned laminate glass initially, and monolithic glass. What are the differences between that? I've got a couple of ones here, but just talk us through the differences between these.
Yeah, so you've got a piece of 10, 12 mil monolithic there, 10 mil monolithic with a satin acid etch coating on it. So effectively, as you said earlier on, strength-wise, typically 5 times stronger than just standard annealed glass, because it's gone through that tempering process, that heating and that rapid cooling. And when it breaks, because of the inherent stress, as you said earlier on, we're trying to put stress into it. Because of that inherent stress, when it breaks, it will break explosively, if that's not too much of a extravagant word, but it will break into small chunks rather than the shards, as Graham said earlier on. Long shards tend to be sharp. You think sort of greenhouse glass as a classic example of that. You don't see a lot of annealed glass in applications anymore, but greenhouse glass was or is annealed. But toughened glass, toughened breaks into small chunks.
And the alternative to that, which we've just been talking about as well, is the laminate glass.
Yep.
So talk us through what this process.
Yeah, so essentially two pieces of toughened glass bonded together with an interlayer. Many different types of interlayer. You've got PVB, which is the sort of more standard traditional method, which is bonded through an autoclave process, which is heat and pressure to create that bond between those two pieces. Also, you get EVA laminates, which don't require autoclave. They'll use a more traditional oven. There's differences in terms of their strengths, their benefits. But essentially, they're both geared towards creating the same thing, which is two pieces of glass, or three or four. I mean, you can extend that out, bonded together to create a glass that forms a barrier then. So when the glass breaks, it remains bonded to that interlayer. So whereas Thermal monolithic or toughened glass, when it breaks, it's gone. When laminate breaks, it remains bonded to the interlayer, it remains in situ. So its integrity as a barrier remains.
So if we look at a typical barrier, Graham, we're looking at a historically something which may have been done as a 15 millimeter monolithic glass.
Yep.
Or might have also been done as a 10+10 or an 8+8
Yep.
laminated glass. Why? Which one's best, and why would somebody look at going one of those?
We've said earlier that we've been doing this for over 20 years, and there's definitely been changes in the industry. I think if we go back 10, 15 years, there's a lot of 10 mil, a lot of 15, 12 mil, a lot of 15 mil, even 19 mil put into balustrade and balcony applications. When it breaks, as we said earlier, those chunks of glass are falling. They're falling down, and a 200 kilo piece of glass is 200 kilos of glass shards that are falling down. The advantage of using the toughened laminate, which we did all see a shift to until the changes, meant that if that breaks, if one of those leaves happens to break on a 17.5 or a 21.5 or even a 25.5, that glass generally stayed in place. So your barrier was retained, and also from a safety perspective, you haven't got glass falling down.
So James, let's bring you in here because I know you've got real world experience with looking at incidents which have occurred. Tell us a little bit about what you've seen as you've risk assessed barriers where unfortunately it's been done wrong, and you've had an incident occur. Tell us a little bit about this.
Okay. The whole idea of a from a balustrade, whether it be internally on a staircase or on a balcony or something like that, that piece of glass there is acting as a barrier. Okay, you're trying to stop a person or an object from going from one side of the glass out to the other. Okay, so right from the outset, the designing of that system is so crucial, which includes looking at many different factors: the environment, the framing system, the actual the bolts and the hinges and everything else that there, whatever is the things that are holding the thing together. So once when you're looking at that, then you've really got to be looking at the scenario that glass is actually going to be in, and actually asking the question: is that type of glass right for that scenario? Right glass, right place. As something that the GGF have actually created on one of their documents, the right glass in the right place. And that goes a lot of the time, that falls by the wayside, because we've had this mentality that the default has been because of people will look at just an impact loading. They'll do under BS 6180, they'll do all the calculations and they'll go, oh, that's okay. Monolithic toughened it is then 10 mil toughened as a barrier, as an infill panel, and it doesn't matter where it is on the building. It's happened so many years, that's the default. So yeah, and I've investigated quite a few instances where somebody's hit a barrier or it's broken because of nickel sulfide inclusion or for other reasons. And then that glass is just, this should be monolithic toughened. When it breaks, it loses its integrity 100%. That containment part of it is just gone.
So one of the situations I'm aware of, which was a really tragic incident up in Sheffield, was a public terrace area. A young child fell through a gap, which was where a monolithic panel had gone and hadn't been replaced when the incident had happened. Really tragic result of that. Tell us about one of the ones which you've investigated. What actually happened in one of those kind of scenarios?
Okay. Yeah, I'm not going to name the actual place it took place at, but it's documented online. But this was it was a school, and a 12-year-old boy was leaving the school, and him and his friend, his mate, were having a game of tag, pushing each other, and it was on this walkway. It was basically a concrete bridge, and there was a huge drop either side of this balustrade or barrier on a small little brick wall at the bottom, and then anyway, the head height or the handrail height went up up to 1500 mil. But these infill panels were 10 mil toughened all the way along.
What monolithic glass? Yeah.
Yeah, well, yeah, 10 mil monolithic. And having looked all the way around the building at the school, found so many issues of glass that had slipped in the clamps and dropped down onto their corner. So they had glass resting on metal at the bottom there, which is another reason why glass can break, glass to metal contact. And what happened, he turned his back to the glass and his mate came up and shoved him. He hit the barrier, the glass panel, and he fell 45 foot backwards. And it was only because of his rucksack, he had it over both shoulders, that actually stopped his head hitting the concrete down below. If he'd not had that rucksack over on that day, he would have died on impact. But that's what we're dealing with.
So sadly, we can't rewind the clock.
No.
However, if we were doing a new scenario and it was using laminate glass, how might laminate glass behave differently in a scenario like that? Where you've got an impact, it's going to break part of the glass. How might a laminate glass behave differently to monolithic?
Obviously, it's going to be dependent upon what's hit it, where it's hit it, all the framing system, the bigger picture, which the industry sometimes, I'm not just mean the glass industry, but I mean people who need to look at the information that's put out there for people to rely on to design and specify all these systems, need to know all this information before they can create the main product. But if laminated was inserted instead of monolithic toughened at height, there you've automatically built in that containment method back there. So as Fraser and as Graham was saying, that when a laminated glass can be made up of different parts, a toughened or a heat soaked or whatever, it can have different parts, and what you're trying to do as it basically is, if one pane of glass breaks or they both break, which it does happen, that it was still, that bonded interlayer will be able to give you that containment, which is the key word with there, it's containment, and hold that in place so that post breakage, it's still plugging that gap.
You built in that redundancy. Exactly. Yeah, so if one panel goes, you've got that second panel. If both panel goes, you've got the extra redundancy of the interlayer. Yeah.
And we've certainly seen this in scenarios over the years where from the statistics we've got of our own use of glass in balcony scenarios over many years, the likelihood of both those going together is a very small probability versus one of them being smashed. And then you've also often got clamping through the glass and handrails and so on attached to it, which help give you some element of additional safety. But with balconies, the norm had become the use of laminate glass by probably 2012, 13 time,
Yep.
there was more and more of the glass manufacturers and processors like yourself investing in plants and so on. The cost of it was coming down versus what it previously had. By the time we got to 2015 or 2018, after Grenfell happened, we were looking at the fire safety as an industry more generally, and we got the hack report and so on. By that stage, trying to find 25mm glass or 19mm glass would have been very difficult. But that's just what it was certainly when I first entered the industry in 2006. And as a result of this benefit, that had become the norm. However, 28th of November 2018, we had the announcement that there would be a ban on combustible materials on the outside of buildings, and that unless it was on the exemption list, fundamentally it wasn't permissible. Now, that exemption list mentioned glass, but also had the wording in a window scenario, which therefore could be extrapolated and is generally interpreted that by it only mentioning that, it probably therefore meant that it is excluded and therefore banned from use even if it's a Juliet balcony 30mm away from the glass, or a balcony balustrade around the outside. So we've seen that since that point. The kind of looks like there's 4 routes which people have been going down. First route is they've switched out all the glass generally. Don't know if this is what you guys are seeing.
Yep.
Generally.
Yep, definitely.
So railing systems might be one choice. The downside of a railing system is it's Class A when it's signed off by building control. The building's occupied, and for the reasons which were identified by some research done by Skies into balcony users and taller buildings, most people felt they had an issue with privacy and wind resistance. So what happens? We put in a Class A railing system, it straight away gets furnished with bamboo screening, wicker screening, plastic screening, all of which are more combustible than the actual interlayer ever was. It's just the other side of the building control sign-off. So we've got that. That's kind of the first practical solution. The second route is people might be looking at some form of solid balcony balustrade. Now, the challenges with that is that if you have got the 1500 you were talking about, something like that, you could easily get less than a 50% ratio, which is specified in BS 9991 of openness, and therefore it becomes treated like an enclosed room. And that has a whole different set of fire parameters on it than a typical private outdoor space. It also doesn't work well for the London plan and for disabled users who, like my mum, who's wheelchair bound, can't actually see out through a solid surface. So the other 2 options is we've seen the use of some monolithic glass. And I'm going to come back to you in a second on this for your thoughts, of all of you. And the 4th option is looking at alternative gel interlayers and so on, which have been created for internal ones and trying to use them externally with fire certificates and so on. But before we just get into those options and talk a bit more about that, what is it about the laminate glass which is not going to achieve the A2S1 D0 requirement, and can this actually be achieved with a interlayer? Graham, from your experience,
From the current interlayers that are out on the market, no. We're not going to exclude the gel interlayers here when we're talking about this. The glass will give you an A. You know, a single monolithic glass, you can get your A rating. I suppose you need to get into the detail of the testing. The 13501 test, in my view, isn't the right test standard to be using for this, because you have to go down to component level. And as soon as you go down to component level, we start talking about the interlayers, which are organic, and they combust. So you're not going to get an A rating through a Sentry interlayer, an EVA interlayer, a PVB interlayer. It's just not possible. But interestingly, if you tested it as a finished product under 13823, I think it is, it's going to pass. But that's not the way the standard's been set up. So no matter what you do, unless you're going down the gel route and with an intromescent fiberglass, you're not going to get an air with the current interlayers that are available on the market.
That's interesting. So I'm interested, have you actually done testing?
So we've tested. We've tested we've done all of the tests, the 13501 tests, and 13501's got the sub-test underneath it. Is it 13823? I think it is. As a finished product. So you can test a toughened laminated balcony panel to 13823. Does it set on fire? No. Does it drip? A little bit. Does it smoke? A little bit. But because you then have to test the interlayer, the individual components, you will never get an A rating on that interlayer. So regardless of the fact that your finished product you make, the product that's going on the balcony, the 17.5, the 21.5, the 25.5, finished product, regardless of the fact that that would get you, you prove it doesn't set on fire or spread fire, because of the way the test set up, you're not going to get a pass. We've done that test. But because of 13501, because of the component tests, you're not going to get through it.
Any thoughts on this, Fraser?
Yeah, no, I completely agree. As you say, you're breaking it back down to the component level. And as Graham's pointed out there, you're never going to achieve it. Even though that component is encapsulated in a product that is an A-rated product, and the exposure really is minimal around the edge. And I know we sort of looked at different ways of trying to encapsulate that unit so that there was no exposure to the edges. That wasn't compliant. And then, really, it's left it open to the gel interlayers, intermittent interlayers, which, there is a smaller supply chain for that. They're broad. Well, they are more expensive to produce. They're more expensive to purchase. And then really that gave designers a difficult choice in terms of, particularly like a retrofit project, for example, do we look at a higher cost product, or do we just opt for, as you pointed out there, do we go down a railing solution, or do we put a solid wall in there, which then again, you're affecting the light transmission into buildings and natural daylight, etc., etc. So we looked at it in as many different ways as we could. And I think we all got caught up in, quite rightly, an attitude towards risk that really went quite extreme, captured a lot of products within that probably didn't need to be. And with a little bit of common sense and with the right testing regime, actually, you can find products that are compatible with what you're trying to achieve, really, which is to mitigate the risk.
It's interesting because there are some slight changes that could be made. As you talked about encapsulating the edge, you could put an alley cap in all the way around it. That interlay is not getting out of there. It's not getting out of that piece of glass. We've talked about the fact it's bonded between two toughened layers. It's not getting to it.
It's only built that very fine edge of the piece of the PVB or whatever it is. Yeah, it's not getting to the main face of it, is it? Or the adhesive side. And actually, I'm going to throw a curveball in here, because my knowledge actually of glass comes from the window film industry. Okay, or going back to the late 70s, early 80s through my father. And this is the thing that I've never actually, and I've spoken to quite a few people within the window film industry from some of the big manufacturers of window film. Window film or clear safety materials won't make a class A1 or A2, right?
Even if it's a bomb film?
Yeah, A1, they won't make an A1 or an A2, it'll be a class B at best, okay? Now, you can get internal films and you can get external films, okay? And it beggars belief that they have not banned window film, clear safety film, blast or safety or security film going on the outside of on the facade or a glass on the outside. They haven't banned it. But that will make a class B. But then, where's the logic? If you're gonna put a complete ban on laminated glass, where that interlayer is got two pieces of glass minimum either side of it, you're doing that, but you're not banning or getting rid of something has got it's got one piece of glass there, but it's got one face of the film exposed. Yeah. Okay. There's no logic. Yeah.
So I think it's fair to test it. I think it's fair to have looked into it, and I think it was probably the right thing to do to look into it, because what happened, shouldn't have happened, should it? So I think it's right to do it, but I just don't think the evidence was looked at properly. And
It goes back to the 1996 EU, which is when they came out with that whole thing of what materials they were going to ban.
Talk us through that, James. Talk us through the 1996 and the exemption piece on it, because I know the 1% is a number which comes in for 1996.
The homogeneously organic material, wasn't it? It was the EU back in 1996 that done some testing on many construction materials, and that's where they came out with this whole idea of combustible sides to it, and it wasn't actually widely distributed itself into the public domain, this document, and so it was only post Grenfell that 1996 document started to surface to then see which things were banning, and that's where the UK government went, that we don't want to put the ban on, but okay, we'll let the EU had already made the decision in 96, so we'll go by what they said, and that's why they threw everything, all these products, all into one basket all at once, and went, there you go, that's it, without any testing first to back up what they've done. So that's kind of the basics of it.
So we're working on the assumption here as well that this was a well thought through or a logical based decision, rather than it was just missing the other wording which should have been in there.
Yeah.
We're not going to get a very defined conclusion on what was the case now, but with the 1% exclusion, that's what led to the behaviour Fraser was talking about, wasn't it? Of looking at edge strips, which could be less than 1%, and that, and with these gel interlayers, a lot of them have a combustible strip around the outside.
Well, we looked at, can we reduce, because it is by weight or by volume. We looked at, can we reduce the interlayer thickness? Then what you're doing is you're essentially reducing the interlayer, which is reducing its effectiveness in terms of fall protection to try and get more towards fire protection. So you're fundamentally losing one of its biggest or sort of best assets in terms of its protection from falling from height to try and meet something else. So yeah, you just end up sort of going around in circles of going, well, I might be able to meet that particular requirement, but my appetite to risk is much lower post Grenfell, which was entirely correct. But because my appetite for risk is now lower, and as soon as you say the word risk to anybody, well, the risk of doing this is this and the risk of doing that, you need to have those conversations, but it's quite an emotive word, isn't it? As soon as people hear it, they just think, okay, how can I mitigate that down? And that's where we found as an industry that laminate just pretty much disappeared overnight.
But it comes down to knowledge, doesn't it?
Yeah.
It comes down to the knowledge of the actual,
What is glass? How is it made? What are its properties? What is it good at doing? What is it not so great in doing? And I think that's where, as an industry, I think we really need to sort of be looking to go back to basics and teaching people, especially with Graham and with Fraser, actually, did you know that glass starts out as a molten liquid? And going through this, and then gradually, when we're talking about risks, the more you start to understand how a product is made from start to finish, you can see all the different steps all the way along. Your competent knowledge base will improve, and then so when you're looking at that risk from a barrier up high compared to where there's no drop to either side in a building like here, in a passageway, then you've already got that competent knowledge base to make that good decision for what you want to do.
And that's a really good point, and the viewpoint on that. Glass was very good, particularly laminate glass was very good at providing wind resistance, a clear view you could see through, and being able to achieve the loading requirements, depending on what thickness glass and interlayer combination you're using, to meet the loading line loads and impact loads and so on, for a balcony or a railing system. now railings will take those loadings, but they will not provide the same wind resistance and the clear view, uninterrupted view and so on, which is why there's an issue in the first place. The laminate glass with a gel interlayer, as you were touching on then, Fraser, also presents a similar sort of challenge because gel does not hold together like a sheet does. And we found that when we did a lot of testing in our test lab, is that if you do break both panels, in the wheelbarrow, swing wall testing and so on, if both those panels break, you've got big chunks of glass and gel combo, which actually you kind of step back from and say, well, the point of a laminate interlayer was to hold things together and make it more safe.
And the definition of what a safety glass is in the first place, because it has to break in a safe manner and not leave pieces of glass that could actually do physical damage or hurt you in a certain way. And that's where you do like the little dice pieces.
That's a really good point. And monolithic glass has generally been considered. James, take us through why it's been considered as a banned item, if you like, under regulations. Which regulation is it?
Yeah, we're coming back to this whole thing around Building Reg 7 and Approved Document 7, which pre-Grenfell wasn't really talked about, discussed, and really pushed out there. And the same with CDM regs. And the two are quite, even though they're two different things, CDM regs and building regs, they're both mandatory. Okay. But when you're looking at the building reg and the approved document side, which building control and also a lot of designers, architects and so forth will look more at that because it's in print form and in there that they go like they would with the British Standard. Okay, they read through it and just do that. So
for clarity, Regulation 7 is about workmanship and materials primarily.
Workmanship and materials, that's right. Yeah.
And it's the only regulation that has its own approved document out of all of them. Basically, in a nutshell, what the Building Reg 7 has actually got in there is there's two key words, okay? And those two key words are adequate and appropriate, okay? And it's basically asking you in a way, this is the workmanship is actually the bit to do with the competence of an individual, whether they're actually designing, specifying, installing. It is kind of a competence reg as well. So they're actually asking you to choose and design and all those other things in there, a material that is adequate and appropriate for the scenario in which you're looking to put it into. So that's where all the competent knowledge all comes into as a bigger picture.
So why is it then monolithic glass? Obviously, we'd seen the instance which had happened, which we talked about. The industry generally moved away from that and got more serious about how they're approaching risk and so on. Regulation 7, whilst it might not physically mention any materials explicitly, the process of working through the design, considering the construction of it, the design of the construction, the maintenance of it, and so on, why have we seen some, and is this something you've seen, some kind of return back to using a bit of monolithic glass in the absence of laminate glass being permissible?
Yeah. There has been several circumstances which I've heard where certain building control authorities around the country are by default going straight back to monolithic toughened because the client wants glass into there. They don't want railings. They don't want a metal panel to go into the hole so it completely blocks off of you. They want those clear sight lines. So they will go, oh yeah, it's glass. We want glass. The client wants it. They'll have glass. So they're just going back to that default of monolithic toughened. And yes, again, it comes back down to what we were talking about before with monolithic toughened. When it breaks, it loses its integrity by 100% as soon as it breaks. So it will then no longer be able to do the function that it was put. Now, this is where actually when you say it to do the function it was put in there to do, this is when you've got to step back and actually look at it and go, well, ultimately, you're plugging a hole.
Yeah.
Okay. You're actually stopping because of like a window in a house. Okay. Irrespective of whether it's in the ground floor or up there, it's still classed as a barrier. And this is when you start to look at a barrier. Even if there's no drop to either side of the pane of glass, that is still a barrier. So once you start looking through all the competent information, you might think, and this is where sometimes the British standards and other approved documents, they will class it as a barrier, but how it's worded and how it's looked, people have looked to go, oh, well, look, you can use 10 mil in that barrier. So the fact that that balcony up there has been classed as a barrier as well, oh, you've allowed that because it's classed as a barrier too, so we can use it up there. And it's again coming back to the definition of the right glass for the right scenario.
The thing with glass, it is a technology, and that technology's moved on. And what we've seen, 10, 15 years ago, everybody had toughening furnaces, 10 mil monolithic, 8 mil monolithic, whatever that happened to be, was relatively cheap and easy to produce. And the laminating technology really was the preserve of the big boys, the glass manufacturers themselves. To put an autoclave in was £1 million, £2 million, whatever that number was. It was beyond the average processor to do. When that technology, as with most things, started to get cheaper, more accessible, more easy, and it's fairly easy to set yourself up as a laminating business now, whereas previously it wasn't. So that technology's moved on, and as James has pointed out there, whilst people look at glass as an aesthetic product first and foremost, they tend to ignore the technical elements. Now, we're completely biased because we're glass geeks in the nicest sense, but most people look through glass. We tend to look at it. I'm sure we're the first people to look at the toughening stamp in the bottom and see what our door is. Then you look at, we automatically look at the application and think, well, okay, yeah, they have used a laminated toughened panel on this hotel balcony or wherever we are, or if we're at the shopping centre, we'll look at the toughening stamp on the escalator. But that technology's moved on, and I think James is right that the regulations haven't caught up with that. And we still see specifications come through, 6180, it's got to be, it's in a sensitive area. What's the most basic product that we can use? Rather than actually looking at, well, actually there are more products available now, rather than just that bit of 6 mil toughened or bit of 8 mil toughened. We can put a laminate in there. And for me, anything at height should be laminated. If it breaks, it is going to fall into that void. And with the best will in the world, a 100 kilo piece of glass is going to retain some integrity as it falls. So,
that's actually quite a good point. So just quickly sort of taking it on, Graham mentioned something right at the very beginning, which I was going to kind of go back to as well, and it's that term clumping. Okay, which is, again, people think that when toughened glass breaks, it just breaks into, and when it falls into confetti, right, it just floats down like little leaves, and it comes down with the larger face of the tiny dice piece. It comes down that way, but it doesn't. It will do both, and it will come down literally like in a clump, size of it, depending on the thickness and the size, like dinner plate sizes, and that's what we call clumping in the industry. And if that's breaking from quite a way up and you're down below and that's coming down at you, 9 times out of 10, that's probably going to be able to hit you, but the sharp point of the glass is going to impale you in the head, and it's going to hurt, and it's going to do some serious damage. And that's, again, coming back to the properties of what glass is, which is where we need to kind of improve on that side of it.
And that's a really interesting point, because there is a lot of energy which is not just, it's not that the pieces just drop down straight either. I think you used the word explosive.
We saw it. I shared with Fraser a couple of weeks ago, where a guy had contacted me and said, James, look, I've had this instance in partitioning like this, exactly the same sort of setup here, and he said, we've got a plaster wall, 3 meters, something like that, or whatever it was, a good width of a corridor, the other side, and I think they said it was it 10 mil toughened, or no, 12 mil toughened, 12 mil toughened in it like that, virtually the same sort of size as that, and it had actually punctured a hole through the plasterboard the other side. Okay, and it physically punched it, and we look and we're going, how's it done that? And it was a pane that was right next door, where there wasn't actually a glass door, it was the end pane onto a framing system. And we're just going, how's it punched a hole through the other side, and that would have gone with some force.
And ironically, the conversation with that chap was, again, to mitigate, because they were concerned that as we said to them, the glass has performed the way it should. It's broken in the manner that it should. The only way to mitigate that risk of it happening again, because it could have been metal on metal contact, could have been poor insulation, could have been an inclusion, could have been any number of things. The only way to prevent that is to use a laminated glass.
Yeah.
And we're not saying that laminate is the right option in every application, but there are a lot of applications where monolithic is not the right product to use, and laminate is the right product to use.
You know, all the way through this, you talk about glass breaking when you could have heat soaked it. You talk about that instance you just explained there, you could have put 12.8 in there instead. And every time it comes back to cost. You know, you've got to achieve a regulation, you've got to achieve a standard, and everyone looks at that. And then how do I achieve that the cheapest way? You know, and that's what happens so many times, that it comes back to cost. You know, even when we talk about heat soaking, it's an extra over on top of what you were paying already.
And a delay.
Yeah, and it takes longer. It takes longer, and quite often it's time and money.
And heat soaking's an insurance policy as well, isn't it? Again, that's somebody's appetite to risk, and they've looked at it and gone, my appetite for that particular risk is not to the right level, therefore heat soaking brings it back down again. It makes them more happier with the level of risk that they've got, which is where, yeah, heat soaking then comes into it. But as you pointed out earlier on, James, when you've got local authorities that are quite happy to use 10 mil, because according to the standard, it's compliant.
Yeah, but I had, right in the early days of when I joined LinkedIn, I got talking to a very well-known name within building control and on LinkedIn, and we had this, not a heated debate, but we had quite a good few words. And ultimately, building control are looking at glass and signing it off because as they see it, if it's not broken, it's all right. They're not looking, oh, what could happen? They're not looking at it like that. They're just going, oh, it's specified. That's why you were always finding 10 mil toughened as a default was going into balconies, balustrades, were acting as a barrier to actually stop people pitching out if it broke. But at their point, when they were looking at it, oh, well, it hasn't broken. There's a gap there that's been filled. We've got to pass it.
I think in fairness to the industry though, post Grenfell, that volume hasn't switched. You know, it's not that 21.5's become 19 mil, that volume's gone.
Yeah.
You know, the vast majority of it, I'd say, has just been taken out the market. And we all know that they could have looked to change to 15. They could have looked to change to 19, rightly or wrongly. You know, they could have looked to it. I definitely haven't seen that. No. I imagine you'd say the same thing. The volume has literally been, not overnight, gradually, it's just been taken out of the market.
And that primarily comes from that thinking had matured quite considerably between 2010 to 2018. The thinking in the marketplace had matured quite extensively to look at it and say, monolithic just isn't really appropriate.
And I think, like you picked up on, Fraser, cost.
Yeah.
You know, we've probably got to a position where it was a tipping point between 15 and 17.5 that actually we could produce it cheaper than you're doing 15 mil anyway.
And part of that was, as you say, that development on the technology happening 2015 to 18 particularly, but also in 2011, the British standard BS 6180, which other than that, hasn't really been updated for a couple of decades, or 3 decades pretty much. Yeah. But they added a note there about laminate glass, which meant that structural handrails no longer needed to be used with the laminate glass, and structural handrails are quite expensive, so there's a double cost reduction. But that coupling together of costs coming down and maturity of thinking increasing, obviously brought us to that stage. So kind of bring this back to laminate glass is currently banned. We know that the government has spent a considerable time and money exploring full-size mock-ups. I know various people have contributed to it. That became public May 2025 when the one of the consultants involved in that announced it in a webinar, what the conclusion of that report was, which deems it as not being a risk to fire load on a balcony. Obviously, we're currently in limbo because whilst that is the case, and it's useful for assessors, no doubt, looking at existing buildings. Where we are right now with new buildings and construction happening now is it still remains an item which isn't listed as an exemption in Part B of the approved document. So I'd like each of your perspective, Graham, if I start with you.
Yep.
Do you think laminate glass should be brought back from a safety point of view, purely from a safety point of view? Do you think it is actually a product which we should be using, which will increase it, or do you think it's a product which will add an additional risk, again, which isn't appropriate for the industry?
Kind of depends how you answer that one. So let me just come back a little bit on that. Do I think it should be brought back? Yes. My personal opinion was that it shouldn't have been taken away in the first place. Like I said earlier, I 100% agree that some testing should have been done just to be sure. We all have our own opinions.
Yeah.
It's not going to do anything. Do a test. Do a test and have a look at it.
Yeah.
Look at the right test in the first place. So I do think it should be brought back, because I don't think it should have been banned in the first place. You know, you had an exemption on the windows, an exemption on the doors. There should have been an exemption on the balcony as well.
Yeah.
Is it safer? It's definitely safer than somebody going to put some 10 mil or 12 mil or 15 mil or 19 mil in. You know, I think we'd all agree on that one. If it breaks, you're left with a gap. If it's monolithic, toughen laminate in there, you're not left with a gap. So my personal view is, one, I think it should be brought back because it shouldn't have been banned. Two, I think as a product, if I'm talking glass for glass, can't really comment on railings. If I'm talking glass for glass and comparing laminate to a monolithic, 100% it's a safer product.
Yeah. From my point of view, commercially, it doesn't make a difference if we're selling a railing system or a BR system. However, I'm a big believer that a balcony with laminate glass, in my opinion, is of less risk than a railing system which has been furnished with combustible screening, directly able to suck in oxygen and to combust. And we've got test data, which we did, a test we set up with the Royal Berkshire Fire and Rescue, where we captured this on video. We captured the laminate glass and monolithic, and the piece of research we did during COVID, which was the document we sent to the MHCLG in May time when they asked us for that. The various scenarios where glass has been present in a balcony instant, actually the laminate glass, there's some really interesting imagery and video footage of how it's broken, and monolithic glass and the gaps and so on. So it is my personal belief that whilst if it remained a banned item, wouldn't mean that you couldn't have a safe, solid one. There is glass and oxygen, which we should have available, absolutely.
Yeah, I totally agree.
And I don't believe that monolithic is the...
You said we've moved on from the monolithic. You know, the industry's moved on. Not just the glass processing industry, all of the industry's moved on. You know, we've moved to laminate. Personally, the other thing I'd add to that is, you know, with railings, what's to stop someone from putting something through the railing and dropping it?
Exactly. It's actually like the sphere the size of a cricket ball. Was it 50 mil, something, or 100 mil?
100 millimetre diameter and it's got to stop.
That's it. Yeah.
Yeah, aesthetically, it looks better.
So you have to try and keep it,
Yeah.
you know, evenly spaced so that you're still getting that light coming through, whereas glass performs that in a solid barrier rather than sectional.
What's your view on this, Fraser? Do you believe it should remain banned, or do you believe it should be coming back?
Well, I think my answer is going to be quite. I agree with Graham. I understand why it was. I mean, we've got a vested interest, and I'm always, and James and I talk about this quite often, that I'm always concerned by vested interests, because that's kind of how we got ourselves in the position with Grenfell to begin with. So from my perspective, you sort of try and take the commercial element, the safety element away from it. I think it is fundamentally a better product than any other glass option there. And obviously I am going to be, you know, biased towards glass, but absolutely I understand why it was banned, and at the time it was probably the right decision to put a pause on everything and just try and de-risk as much construction work as possible. But I do think all of us were left scratching our heads at the time thinking, you know, this seems crazy to me. You know, why We know that it's not going to combust. We know that it's encapsulated. Okay, we know that it's got an organic material in it, which causes a problem potentially. But I think we all looked at it and just thought, well, this doesn't quite make sense. So for me, in that particular application for balustrades, if it's going to be glass, it has to be laminate all day long for me, and that's always been the case.
I think it's fair. You're right. We do have a vested interest, but we can back it up.
Yeah.
And it's not like we're just saying it because we believe it.
Yeah.
We've got evidence. We've been talking about this now for 7, 8 years. Look at this test. Look at this test.
But the thing is, both you two are actually at the beginning of the process. You're not just going out and flogging glass, are you? You're not a double glazing salesman. You're not a 24-hour glazier. You're actually there making that. Well, you're getting the float delivered to your to thing there, but you're then doing all the other processes to then create these products. So you've got more of a better knowledge thing there, which is then going to help to those that are on the outside who then need that competent knowledge from that aspect, and that's something else has to be.
Haven't we?
Yeah,
We see, we work on multiple projects. It's not just balustrade projects. It's office partitions, it's kitchens and bathrooms, it's all those kind of things, and it is very much choosing, and as you said it on, the right glass for the right application. And for me, education is really important there. We get a lot of designers, architects that come to us, and the first question we ask, if you haven't got drawings, where are you using it? What's it for? And then we use our experience, we fall back on our experience to make recommendations. Now, we're not designers, or we haven't, I don't know if you've got a PhD or anything like that, but we've been in this industry long enough to know what the right things are to use in the right places, and or to at least steer people as, have you thought about that particular risk with using that type of, thought about this?
It's not just nickel sulfide, is it? That's going to cut that itself.
Great, I've got an order, let's go out, manufacture it and send it. I think there's a responsibility on us, within the industry, to make sure that people are making the right decisions.
Yeah. James, what's your opinion on this? Should laminated glass be brought back? Should it remain banned? Haughton, what's your thoughts?
Put me on the spot. No, to be honest, I totally agree with both of you, or from the processing and whatever, and whether you've got a vested interest to do it or not. The fact that this all goes back to the 1996 document, okay, from whatever, we can all agree, I think, that the glass and interlayers has progressed in terms of manufactured design, whatever, from way back when it was originally tested in 1996. It was 20 years pre-Grenfell when that document was put out. And then where are we now? All right, we've got another 10 years on top of everything there. So it's ultimately, yes, they had to do. They did the right thing, but I think again, where we're all looking at, like with the Building Safety Act, we're looking at all the things that are going on with the construction industry as a whole, with competence of individuals, organisational competence. It's taken its time, and I think this is actually one of the crux of it. Is why is it dragging on? When they banned the material, where was the urgency to actually go, right, we've thrown all these products in, we've got this document from 96 saying all of that, but when you look at construction now, or MMC, modern methods of construction, glass is basically buildings are being built out of this stuff. Yeah. All right, so we need to get a bloody big move on, and so, right, let's go and look properly. Right now, we're not going to wait 2, 3, 4 years down the line before we actually even look at it. We need to move on it, because the industry needs to use this material day in, day out, and it needs to know what it does and what it doesn't do. So yes, it was right to put the ban on it, but I think in my perspective, it's taken too long to still drawing this out to where we are now, and we're still no further down the line.
Yeah. So from our aspect, we also working internationally. UK is the only market where glass is not permissible on balconies. There's a lot done in North America. There's a lot done at the other side of the world, New Zealand, Australia, Ireland. Yeah. We do a lot of glass as well. They have change the wording of the exemption list. Fortunately, looked at it in a very balanced way, and laminated glass isn't excluded in the same way as, it's not got a window scenario put in the exclusion list there, which means that you can use laminated glass there, and rightly so. But a few little tips, something which we have always done from as far back as I've been at Sapphire, was making sure that you've got mechanical fixings going through glass. We never used glass D-clamps unless they had a pin or
etc.
so they had bolted connections. Over in Canada, they use the edge of the balcony, pushing it out slightly underneath glass if you've got glass, laminate glass, so that if it fell, it would fall onto a platform, if you like. But is there any scenarios like this which, if it was brought back in the current state, but there was an additional requirement, is there anything which would be useful, which would be wouldn't prohibit the use of it in the way that would be normal for glass scenarios, but at the same time would add some kind of additional safety requirement which might have been avoided? I'm thinking here of things like, the old clamping shoes and so on, which everyone in the industry historically tended to use with wedges and stuff like that, and so on, the D-clamps and so on. Are there any scenarios here which you think would be useful to actually add some other definition around it, which is currently missing?
I think there's some scenarios from your side as an installer, as a manufacturer. I think from our side, from the glass side, I imagine it's more on the material. We talk about glass and we all get glass from reputable sources. The glass is Class A anyway. Interlayer. PVB is not just PVB. PVB can come from many different suppliers from many places around the world. So if there was an exemption brought in, maybe it could be specific on the interlayer. It could be specific. It's not going to be specific on the glass because it's Class A, but EVA is not the same as PVB, it's not the same as central glass, it's not the same as TPU. So there's many different types of interlay that can be used. And there's thicknesses of interlay. And I imagine when you look at the test data, it's different. A 0.76 might be a B, a 152 might be a C. So where are you going to come in on the exemption? How are you going to determine at what point is it okay and is it not okay? And we're not going to laminate with a 0.38 because it wouldn't get the load in, it'd be a nightmare to laminate it anyway. But so there are going to be different ranges there, and I wonder if a compromise could be to say laminated glass is back or is exempt, but it must be X, Y, Z. And then it's not a complete fallback. It's not a complete, we got it wrong, but we've tested it, we've looked at it, we've seen the evidence, we think that this is acceptable.
Do you say you allow certain compositions rather than...
Well, it comes back, doesn't it, to the whole testing and certification process, doesn't it? Because like with the ACM at Grenfell, individually, products are all right. But once you put those individual products into a system, nobody tested that end product, that end system. And I think that's where, again, when you're looking at the designers, the architects, and all those people there that need to rely on the information from the manufacturers of the individual products, and it not just be sales patter, okay, that they go, look, and look, Nick and Fraser and stuff about my thoughts about the EN 12600 flat glass impact test, and how it's always the glass is in a particular scenario, size, width, whatever, okay? And then you can take that result and then use it on other different sizes. And then, but then that piece of glass that you then put in situ in a real life situation has never been tested, okay? So we're back to that. So I think that's something that I think that possibly will need to be looked at as well, the actual testing side of it. And yeah, with different parts to it.
I think you sort of, when you go back to declarations of performance,
yeah,
which are all, we've all been working through now. OPSS are out there making sure that people are doing it in the right manner. And the amount of times where you can put no performance declared, no performance declared. But when you look at a toughened laminated panel, which performance are you declaring? Are you declaring for the toughened element to it? Are you declaring for the interlayer?
Yeah.
In which case, to try and get test data for the interlayer can be really difficult. I mean, I've tried many times to sort of try and zero in on the actual performance. You're not looking at the performance of that product as a whole. And again, that's where I think you're right in terms of looking at if it does come back, it's probably not right for it just to be a free for all. Okay, any composition works, any thickness, off you go. It needs to be sort of brought into that regulatory regime. Whereas at the moment, it's bad, it's banned, you can't use it. Bring it back in, but bring it back into the light. You know, let's actually start looking at what the physical performance is of some of these elements to them.
And I think there's a few simple things, isn't there? And probably most of it, the thinking is fairly mature in the marketplace anyway. It's like, for example, exposed edges to a laminate is more likely to get delamination issues and so on from the weather. So, but it's also more vulnerable to impact or to a cigarette butt or something. Yeah. So simple things like having a handrail on top of glass would be an easy requirement. Bolted connections that if the interlayer does fail, you've not got a sheet which can slide around. Those are some simple things. But James, just conscious of the time and wanting to wrap this up here, maintenance isn't something we particularly talked. And you talked about metal to glass contact. I'd like your thoughts on a couple of things. Firstly, any particular maintenance considerations, but also if we are implementing a new product, say it's a newly created one which actually achieves a Class A interlayer, or if we're using one of the gel interlayers which have been intended for internal use, which might have challenges we haven't foreseen at this stage, we don't want that to become another rack situation 10, 15 years down the road. But what happens if you do end up with a scenario which 15 years time you've got to replace and there's still no exemption, and therefore you've got quite a dynamic. Talk us about that sort of maintenance piece and consider.
Yeah, well, maintenance of glazing systems is another topic that I think doesn't get talked about enough. I've had quite a few instances over the last few years where talking with housing associations, owners of properties and facilities managers, and when you start talking to, and then a lot of the time it brought me round to talking about that incident I said about that child that fell from height, and start to talk about that, and you think, oh, okay, well, this thing's outside, that you're going in and out of a door how many times a day, these things, or hinges, automatic opening closers, all that kind of stuff. They haven't got an infinite life. Okay, they've got to, just like a car. You have parts in that are out to all the elements. They're going to weather. They need replacing. They need checking. So it's no different to any parts in a glaze system. Those parts then need to be looked at and maintained, including the fixings, making sure the gaskets are all, and the fixings and the bolts to the floor are all torqued on a regular basis to make sure that because ultimately, if the architect or designer has then looked and done all the calculations properly to come out with that system, that's based on a brand new system. Okay, that's based on brand new bolts. All the bolts and everything are all torqued to the right things. The gaskets and everything are all brand new. But over the years, these things weather. These things get slackened off. And the amount of times that I've seen things like that place in that school, where the glass had dropped down on one side on more than one time, and the corner had rested on the metal square base plate of the post. And there's your glass to metal contact. So yeah, maintenance of glazing structures is such a key element.
That's what you say. A car gets an MOT once a year, doesn't it? But
yeah,
a building doesn't get an MOT. And again, if they're exposed, it's complex systems. Systems are getting more and more complex as we go. So yeah, maintenance, I think, something that often gets overlooked.
Yeah.
So in wrapping up, the intention of this discussion was not to push a particular suggestion. I think it's clear from the discussion that generally laminate glass is believed to be a very good solution in many applications. However, the decision making and the thought process from what is adequate and what is the best in the scenario which is being designed is something which needs consideration on every project on a project by project basis. It's not a one size fits all scenario. but also the alternative to laminated glass, the monolithic one we've talked about, generally, I think the conclusion amongst everyone here is that it is normally less appropriate to use a monolithic than a laminate, and in some cases is actually should be considered as a banned item under Regulation 7 if you're putting that thinking and thought process into it. So thank you very much for your input. Appreciated your viewpoints, and we look forward to the consultation, which we understand is due out in the not so distant future from the BSR around various parts of Part B, but also including the question about whether laminate glass is appropriate for the external envelope of a building.
Thank you very much.
Thank you very much.
Thank you.